To Developer Days. This is the Cloud Native Network Function Orchestrator. My name is Jesse Wayne. I'm the product manager for CNFO, and with me is my colleague Nirali Vasoya, who's the technical leader for CNFO. And today we're going to be speaking to you a little bit about what CNFO is and why we've built it, and we'll be showing you a demo of CNFO with a new containerized version of CPNR. So first, a brief introduction. Who are we? My name is Jesse Wayne. As I said, I'm the product manager for CNFO. And 3 quick facts about me. I want to build things that make people's lives easier. NSO and its function packs are arguably doing that. I want to lower the learning curve for NSO. It is a very hard thing to learn. I joined the team about 6 months ago, and the learning curve is very high. And then unrelated, I have a very beautiful dog. Here she is. She's gorgeous. Her name is Molly. She has 1 white paw.
Hi, and this is Nirali Vasoya. I've been with the core function pack team since the NSO team was acquired by Cisco. These are some of the interesting facts about me. I never said no to a dessert. I want to make NSO adoption easier for customers by building tooling around it and making it easier to consume. And I enjoy building things in my free time.
Okay, so to start us off, why did we build CNFO? We'll build up some context around why this product exists. So to begin with, it's not just about CNFs. The landscape that we're operating in is composed of 3 different domains: physical network functions, virtual network functions, and cloud native network functions. And none of these domains exist in isolation, right? It's not just CNFs, it's not just VNFs, it's not just PNFs. The environment is realistically composed of all 3 network functions, and it can do so, or it can exist with a mixture of any of these 3. You can have 1 of them deployed, 2 of them deployed, or all 3 of them deployed. So whatever you're using to manage and orchestrate these network functions needs to be capable of handling any mixture of all 3. One other note here, it also needs to be able to handle the migration from one network function to another. So for example, if you're slowly migrating from virtual network functions to cloud native network functions, you're going to need an orchestrator who's capable of helping in that scenario. So to add some complexity here, the deployment scenarios that exist across network functions are quite diverse, right? You see a simple bare metal situation for a VNF as well as a CNF, but you can see mixed scenarios where you have CNFs running on VMs. You also have platform as a service or infrastructure as a service scenarios such as with AWS EC2 or AWS EKS. So similar theme here. The orchestrator that you're using needs to be able to handle whatever deployment scenario is thrown your way, whatever environment you need to deploy in. So that is exactly what we are building out with NSO as a whole, which is composed of these 3 different elements: TSDN, NFVO, and CNFO, which we are talking about today. The real value add here is that you're essentially working with 1 engine, with 1 database that can handle any combination of the aforementioned domains. This is translated into from a user perspective, we're abstracting away the fact that all of these device types are different. So put another way, you can write 1 service that rolls out to all 3 domains and treats them as 3 devices, regardless of vendor, domain, deployment scenario, or even, in the case of CNFs, the type of Kubernetes that you're using. So from a user perspective, your experience is going to be consistent whether you're using NSO's GUI, the CLI, or you're interacting with it with an API. So to talk about these value propositions up front, end-to-end orchestration from service to device, that's the main driver for NSO. We're also talking about multi-vendor device support, and that means many things here, right? We're abstracting away not only the vendor, but the device type itself, whether it's a Cisco device, an Arista device, or Juniper device, whether it's a CNF, a VNF, and like I said, even the Kubernetes type, right? It can be EKS, Tanzu, vanilla Kubernetes. We don't really care. There's operational consistency. Like I said, the service is going to treat each of these device types exactly the same way. From the user experience, it doesn't matter. And then it's also about orchestration at scale. So specifically in the case of CNFO, Kubernetes and Helm can handle a launch scenario in 5 data centers, right? That's very good at doing that. In fact, we're actually not changing anything about the way that Kubernetes interacts with CNFs because it does it very well. But where it starts breaking down is as those deployment scenarios grow in scale. So this is a good segue. This is a quote from somebody within Cisco who is deploying what you're about to see, CP&R, on about 45 sites. And she said it took her half a day to get their environment loaded manually, so without CNFO. So you can imagine with CP&R, we see deployments anywhere from 40 to 200 sites. So as you approach 200 CNFs, it's not a great experience. But with CNFO, you're going to be able to reduce that time quite significantly. So what is CNFO? What does it actually look like? When you look at the CNFO architecture, CNFO is housed within NSO and it's communicating outwards to a CNFM, which sits within a Kubernetes cluster. Within each of these clusters, there's one CNFM pod, which is managing. CNFM stands for the Cloud Native Function Manager, managing all of the CNF pods deployed within that cluster. To zoom in on the CNFM itself, just note that this is not representative of the actual architecture, but of the action taken by CNFM. So CNFM is composed of a request handler, a notification handler, a Helm client, and a Kubernetes client. The Helm client, Helm may be a new concept here, but the Helm client interacts with the Helm CLI, which communicates with an external chart repo. You can think of the Helm charts that are fetched from the chart repo as empty templates that are filled by CNFO and predefined variables in CNFO. We'll see those in the next slide. The Helm CLI translates these into YAML files, which it hands to the Kubi API server, and the Kubi API server uses those Helm charts to deploy the CNF pods. Then the Kubi API communicates back to the Kubernetes client within CNFM to communicate status about the CNF pods, and the CNFM hands those status updates back to CNFO via netconf. CNFO close-up. So the Helm chart variables that I referenced before are going to be defined here in the CNF descriptor and the CNF instance, both of which are handled as Yang models. So you can define or think about the CNF descriptor as the place where static characteristics are defined that are going to remain the same across CNFs, whereas the CNF instance is where specific items to a CNF, such as the cluster name, the namespace, or any other variables that could change across CNFs will be defined. This is also where the CNF service will be defined and the CNF NED to speak to the local CNFM. And I'm going to hand the rest of the demo over to Nirali.
Thanks, Jesse. So this is how the entire solution would look like in detail if you had to put together physical devices, VNFs, as well as CNFs. So starting from the top, you have a typical OSS BSS system at your service provider, which can integrate with a custom NSO service on NSO via available northbound APIs from NSO. And then under that, you have 3 different function packs. One is NFVO plus NEDs, which takes care of VNF lifecycle management. The other one is CNFO plus NEDs, which what we are going to look at today in the demo, which takes care of container lifecycle management. And then you have your physical network functions and the NEDs taking care of all the physical devices. In terms of NFVO, the stack looks pretty much how Etsy Soul defines it. So you have your VNFM, which is a Cisco ESC in this case. and the integration happens via SOL3 or NetConf interface. Under ASC, you have your OpenStack APIs talking to any infrastructure manager, VNF infrastructure manager, which is OpenStack or VMware in this case. And then you have VNFs getting spun up on that infrastructure. Similarly, if you look at the central piece where we have CNFO and the NEDs, we have an equivalent CNF manager, which is equivalent of your VNF manager to manage CNF, called Cisco CNFM. It is built on top of ConfD engine, along with some other APIs that we saw earlier, like Helm client and Kubernetes and so on. Now the CNFM talks to the Kubernetes environment, or the in this case Red Hat OpenShift, or it could be any other Kubernetes flavor. And the CNF infrastructure is basically your Kubernetes engine, which can deploy any type of Kubernetes objects that you have requested through the YAML files that are pushed from CNFM to Kubernetes. And for the physical devices, it's pretty simple. It's anything that your NED can integrate with. So your REST or a typical CLI interface, or it could be a NetConf interface. Now, let's get into the demo part. So what we are going to see here today is a CNF. It's a real CNF, which is Cisco Prime Network Registrar. CPNR has primarily three types of services in container world: DNS, DHCP, and IPAM. Our focus is going to be on the DNS service today. In terms of clustering, it has, at a high level, it has two clusters, regional as well as local. Regional cluster is a CNF or a pod that would manage configurations of the local cluster as well as product licensing and so on. And the local cluster is the one that provides the actual service, in this case, DNS caching. And in a typical deployment, you would see one regional and multiple local clusters. Now, going into the setup, how it looks for the demo. So on NSO, you have two services. One is CPNR shim service. It's a small service that's written specifically to avoid the complexities of CNFO or the CPNR Helm chart, and only expose what the user cares about in terms of configuration. And then you have your CNFO service that talks to CNFM pod on the Minikube environment, and CNFM pod would then create CPNR regional and local pods in the demo namespace. Now, in this case, Minikube is a development environment for Kubernetes. And the setup that we are going to look at today is going to have just one master node. There are no worker nodes in this case. And then demo namespace is a namespace that is created specifically for this demo, which would contain all the resources that we create through CNFM pod. Now, let's look at the CNFO call flow. So at a high level, we have four components here. You have your CPNR service, your CNFO, your CNFM, and the Kubernetes cluster itself, in this case, Minikube. The flow would start with an OSS DSS request coming to CPNR service for a service creation. Once we receive the service create request, it passes on to CNFO, and a CNF instance is created for that particular service, which in turn sends a netconf edit request to your CNFM, which has been deployed as a pod in Kubernetes. And there's a request handler that takes care of this incoming request, which would then, with the help of the Helm client, send a install request for the chart onto the Kubernetes cluster. And once the pods start coming up, we'll start receiving notifications on the watch that we have from CNFM to Kubernetes. So the notifications are coming from Kubernetes to CNFM. The notifications are being handled and messaged so that they can be sent as netconf notifications back to CNFO. Now, once these notifications are received at CNFO, the service plan is updated. CPNR device is onboarded on NSO device tree, and the service is redeployed to mark the plan complete. And once that is done, the day one configuration is pushed on the CPNR pod. Now, let's get into the actual demo.
So maybe you can start sharing your screen for this part, Nirali.
Yes.
Yeah, I'll stop sharing.
Okay. So I have two tabs here. The one on the left-hand side is our NSO, and the one on the right-hand side is going to be our Kubernetes cluster. So let's look at high level what we have here. I'm just going to close this and open it. I lost this session. Sorry about that. Okay. So this is our Minikube cluster. If we look at the nodes, we have just one master node, and it's also the control plane, right? And then we have our CNFM deployed as a pod here. So if we do a get pod in the demo namespace, you would see your CNFM running here. Now this CNFM is added as a device on your NSO. So this is where our NSO is running. So let me get into the NSO CLI. And we look at the packages that we have here. So you have your Cisco CNFO, which is your CNFO service. You have a CPNR NED in order to be able to configure day one configurations on your device. You have your CNFM NED in order to communicate with your CNFM device or the pod that is deployed here on Kubernetes. And then you have your CPNR service. This is a shim service where we create the CPNR service, which in turn talks to the CNFO. Now, let's look at what we have pre-configured here, right? So one of the things that we have here is this CNFM device onboarded as a device on NSO. So you can see that if we try to look at some of the configuration that we have on this device, there are some pre-configured things here. One is, how do I talk to the cluster? So in this case, we are saying I want to talk to selective namespaces, which is, and in that case, I just want to talk to demo namespace from this particular CNFM. And I want to use service accounts for that. Okay. And then we have a bunch of repos, Helm repos that are configured. So we are saying there's one repo called Bitnami. This is for something that will help us deploy Nginx pod. And this is for the CPNR. So you have your both your repos configured here on CNFM. Now, there are a few operational commands that could help you see how CNFM is connected to the cluster. So you could do a show device, CNFM clusters, and then you can look at the status of the cluster that is connected. So here we said the cluster is demo cluster. My namespace that I'm talking to is demo. And with a timestamp, it shows whether it's connected, or if this was an error, you would see a timestamp as well as an error on why your CNFM cannot talk to the cluster. Okay. The other thing that is configured on the CNFM is netconf notification subscription. So we can look at the status of this notification stream as with this. So we have the subscription in order to receive the notifications from CNFM to CNFO. And this is the standard netconf notification that you would have with any netconf-based device. Okay. Now, to start creating your CNF onto your CNFM, the first thing that you need is a CNFD, so CNF descriptor, right? And this is something static that is built from a Helm chart. And there's a neat utility to point to the Helm chart and say, these are the things I want to configure in my CNFD. So the command looks very simple. You do a CNF build CNFD. The first thing that you need to provide is what device, right? So you'll say, I want to go to the CNFM device. What is the repo name? Let's try to build a CPNR CNFD, right? So CPNR repo. What is the chart name that you are interested in? So this is something that you can add based on the name of the chart that you are dealing with, right? So in our case, it will be CPNR local, and then the chart version. So you put the chart version, and then you say, what do you want to name your CNFT? So in this case, I'm just going to call it test, since we're playing with it, and then you can say copy, and you can copy either all the Helm values if you want, so that you could be configuring any of these values from your service, or you can have specific values copied, except the ones that you don't want, or you could have exact values that you want to copy from the Helm chart. So let's say if I try to get only, I want to only change my image repository. So it would look something like this. Right? So you say copy all except image repository. Now, when we do that, the CNFM would go ahead and build the CNFT, and it would be copied over here in the CNFO. So now you can go into configuration mode, and you can do a show CNF, CNFT, CPN, and the CNFT name test name that you had was test. So you do a CNFT test, and this is how it would look. So you have pulled all the key value pairs except the image repository, right? And you can play around with this based on how much of your Helm chart you want to transform into a CNFT or the definition. Now, let's try to create the CPNR regional pod or regional service so that we can start managing some local pods. So creation of the service is something like this. If you see here, you're saying simply saying this is my service name. I want to call it CPNR regional. This is my CNFT. These are some of the pre-populated CNFDs that I have here. So I have CPNR local, CPNR regional, and Nginx. Okay, and then you can specify which cluster you want to deploy this on. What is the namespace? And let's say if you try to give a namespace XYZ here, your commit is not going to go through it. CNFM is going to complain that I'm configured to only manage demo namespace. So there are a few validations like that. You give your chart version, you point to an auth group that you want to use when you onboard your CPNR regional device. And then in terms of values, we want to just say, where should this regional pod go? So I want to point my CPNR to be deployed on this worker node called Minikube, right? And this name matches the node that we have here, which is called Minikube. So let's deploy this, and then we'll go to NSO UI to see how the plan progresses. I'm under CNF. I go to the CNF plan, and this is how it looks, right? So this is still in progress. We'll see this expanding as the pod comes up. You can also go and look at the node here in the demo namespace and see the CPNR regional pod coming up. Now, there are a few more things that are associated with the service that we'll look at as soon as the service is onboarded. As you can see, there's some progress. So we received the CPNR regional deployment here, which is called stateful set in Kubernetes. And this is a pod that got onboarded. Okay. Now let's look at different interesting things that we can do with this service. Right. So we go back to CNF and let's look at the CNF instance result. So this is some of the operational data that is stored under CNF result for the service that you have deployed. And why is this interesting is this is a lot of data in terms of northbound user, but there might be some details that you might be interested in showing to your user for each of the objects that are deployed on Kubernetes, right? So you can pull the data from here and have an abstract layer that can be built on top of the CNF result that can highlight what is important to the user. So for example, in this case, it shows that it has one stateful set in this demo namespace, which is alive, and what was the message in Kubernetes around that time, right? And what were the number of replicas that were requested, how many of them were updated, what is the current available replicas, and how many of them are ready. Since we have deployed just one pod or one instance, we see these values as 1. The other thing that is interesting is the pod itself. So you see your pod name here, and you also see the information regarding your pod, right? What is the host IP and so on. Which stateful set it is related to, and such. Now, there's also a small table that tells you at a high level what things were deployed from your Helm chart. So in this case, it shows that we have deployed 2 config maps, 1 service, and 1 stateful set resource in Kubernetes. And this shows what were the desired count and what is the available count now after the plan is up. Okay. We can also deep dive into one of these elements and look at the actions that can be done. So you can go to the pod and you can say details. So this is an action that is really cool that mimics what you would see if you were to do a kubectl describe command on the Kubernetes cluster, right? And that is something that you can trigger from NSO and then from your service plan. You go here, you do a run details action, and it lists down all the details about your pod. And this has everything that Kubernetes exposes, right? So if you were to take some of this information and show it to your northbound, it can be simplified that way. But all the information is available, like the pod IP or what were the different statuses or the stages that your container went in before it came up, right? So your pod was scheduled, and then the container became ready. And once it was ready, it was marked ready at this time in Kubernetes. So these are some of the actions that you could do on your result. There are a few other actions that you could do on your service instance itself. So let's go here on the service instance. And look at the operations here. So under operations, you can run some of these Helm actions as well as kubectl actions. So let's say I want to see what was the history on my chart that I deployed. You could do history and run this action, and you would see when it was deployed and the install was completed, right? Or you could do a template. So let's say I want to see the raw template that was pushed from CNFO to CNFM and then CNFM to Kubernetes. So you could just do a template here and run this action. So this would show every tiny element that Kubernetes understands, right? And all, like for example, this is the day 0 that was pushed onto the CPNR pod. And you would see the entire manifest that got generated on Kubernetes. Okay. So these are some of the actions that we have here. You can also do kubectl actions. So you can, let's say I want to see what all directories do I have in my pod, right? Since this is a Linux-based container that we have deployed. So you could do a kubectl exec and then select your pod. You can select your container, and you can give some commands. So let's say I just want to list down the directories that I have in my container. So do a ls ltrh, and then this would list the kubectl or the directories in your container. So this is really neat. You do not need to go to your cluster, log into your pod, and try to run all these actions. You can do everything from NSO. Okay. Now let's get back to NSO CLI and try to deploy authoritative DNS pod. What that would do is it would register some of the domain names and work with the regional pod to give a DNS name discovery service. So let's try to deploy that. This is how the service looks. This is a little complicated in terms of, it looks complicated, it is not. it is because of this huge DNS names that we have here. But essentially what you are trying to say is this is my regional IP where my pod is deployed. My worker node here where I want to deploy this ADNS is Minikube. And it doesn't need to be on the same worker node, right? It could be any other worker node. But in this case, since we are in a development environment, it goes to the same worker node. And some of the configurations to say this is where my DNS service needs to run. And these are the zones that get configured for the DNS service. And then these are the resource records that I want to discover based on this DNS service, right? So let's commit this and look at the plan for the service. You go back here and you have your ADNS here. Again, this the plan would look a little bit similar to what we had for regional pod, and this also does the device onboarding. So in this case, we could, while we wait for the plan, we could see the devices that are onboarded here. So when we started, we only had CNFM, but since we deployed the regional service, we now have the regional pod also onboarded onto NSO. And once we'll have the ADNS, I think we should be done here. It gets onboarded onto NSO. So I can go back here and then you can say device list and you'd see your ADNS getting onboarded here. Now, let's try to do a DNS lookup on the resource record that we tried to configure. Right? So if you go here and run a dig on it, so I'm saying this is my server where my ADNS is running. This is the port number where the query should be looked up. And this is the resource record that I have. So if we do a dig, there's no output that we get, right? So we couldn't find the server. And this is because ADNS is configured to have explicit acceptance of the DNS record and also allow the action to reload the DNS records before it can answer to the queries, right? So that is something that can be done with the NED, and this can be very well be automated. But in this case, it is manual since the use case that we have been testing with is for manual approval of adding new DNS records. Right? So you run something like this on your device. So you're talking to your ADNS pod through the NED, and you're saying, reload my DNS server, right? So you reload my DNS server with the configuration that I just pushed through my service. So once you do that, your CNFO, CPNR would reply back successful or failure based on if the DNS server comes back up successfully. And you can then hit your or do a NS lookup on your record again. And this time you would get back a response from the server. So you would see what IP address it maps to, right? Your domain name, what IP address does it map to? So this is this CNF that we wanted to highlight today, and this is a network function. It does DNS functionality in the network. Now, there's one more thing that we could look at here is how we can scale these pods, right? So we deployed one instances of each, but how about scaling this? So this container doesn't inherently support scale right now, but let's look at something that does. So we'll pick an example of Nginx, which is widely used, and we'll say, and we'll keep it simple. Let's say we'll deploy it on the same namespace, we'll deploy it on the same cluster, and we'll say I want just one instance of Nginx, right? So let's commit this, and then we'll go back here and then look at the pods that get deployed here. So you can see that Nginx is coming up here, and of course, if you go and look back at the plan, you would see it in the plan as well, right? So here, it's pretty quick. It gets up in few seconds, but as you can see here, different components are listed on the plan. Now, what we want to see here is how do I scale this? Let's say I want to change this replica count here to 3. So let's try to do this from UI. It's pretty simple and very neat. So you go to CNF, you go to your CNF instance, which is Nginx, and then you go and say you want to change your replica count and change it to maybe 3. Okay. So we'll go to the commit manager. We are changing the replica from 1 to 3, and we're going to commit this. And let's go back to the plan, and we'll see how the plan progresses. We go back here. And there you can see how the plan gets updated as the new pods keep coming in, right? So, and the pods are still in progress. So if we go to Kubernetes and look at it, okay, now they're up, but you would see 3 Nginx pods here, right? So you could scale up into multiple instances. Now, let's say I want to scale down. So it's a similar procedure. You would go to your CNF instance and say that I want to change my replica count to be 1, back to 1. So we're scaling down in this case. And then as you can see here, old is 3, I want just 1. So remove the extra pods and then you commit. And go back to the manager. Look at the plan. And you would see the plan slowly getting removed or backtracking. Right? So this should go back to what we had seen previously. You would see just 1 instance remaining once the plan is done. Now, the plan updates are coming based on the notifications coming in from CNFM, based on the watch that it has on the Kubernetes. So it's a live reflection of what's happening in Kubernetes, and the pods are gone. So this is as simple as this. This is how you scale down from by using CNFO. And that's all for my demo today. Thank you for listening.
And then I think we have 10 or 15 minutes for questions.